question 8. Okay, so here we're given with a function, a rational function, which have a numerator and denominator. And in A, we are asked to write down the equation for the vertical asymptote. So the vertical asymptote is the value of x that set the denominator to 0. The denominator is x plus 4, and therefore when x equals minus 4, the denominator will be set to 0. Here you also have to check that this value of x does not set the numerator to 0, which is not, and therefore this is to answer the answer for A1. Now at A2 we have to find the equation of the horizontal asymptote. So for the horizontal asymptote, we are can see here that the powers of x, the highest powers of x in the numerator and the denominator are equal. In that case, the vertical asymptote equals the ratio of the coefficients of x. So in the numerator the coefficient of x is 4, in the denominator the coefficient of x is 1, and therefore the equation for the horizontal asymptote is y equals 4. This is the answer for A2. Part B, we need to find the inverse function of f minus 1 of x. So for that we take f, the original one, and now let's fx is also y, and in order to find the inverse we isolate x as a term of y. So now we have a term, we have y isolated as a function of x, and we want to do it the other way around, so x as a function of y. So I will get y times x plus 4 equal 4x plus 1. This is because here I multiplied by x plus 4. Now I continue to develop it, and again what I want to achieve is x as a function of y. So I will now bring all the x terms to the left hand side and all the other terms to the other side, and here I can take x out, and divide by y minus 4. And now the last step in finding the inverse is we simply now take this term and write it exactly what we got here, but we replace the role of x and y. So we write 1 minus 4x divided by x minus 4. So this is the answer to B, 1. B2, we have to also calculate the inverse function using an algebraic approach. So we first have to do a reflection in the y-axis. So if we have the function y equals 4x plus 1 divided by x plus 4, to do a reflection in the x-axis, sorry, in the y-axis, we simply replace x with minus x. Then we will get minus 4x, because instead of x we have minus x, divided by, again, minus x plus 4. And here this is reflection in y-axis. Now we want to do a reflection with the x-axis. And for that we replace y with minus y. So we add this term, and now I will put minus y instead of y. Now I simply organize this equation to have y in one side and the rest in the other side. So I can multiply by a minus 1 here and get that y equals minus 4x plus 1. And this multiplication by minus 1 I will do here, and I will get 4, no, sorry, I will get here x minus 4. And if I will do one more step and simply write it like that, then this is exactly the term that we already got in the previous part. So this is B2. Part C. We have to find the intersection points of f and the inverse of f, which are called P and Q. We have to find the x coordinates of the intersection points. So we can simply equalize the two functions. F is 4x plus 1 divided by x plus 4, and the inverse of f was 1 minus 4x divided by x minus 4. So we write down this equation to find the intersection points. This can be inserted to the calculator to get an immediate answer. I will show you the calculation. It's not that complicated. So I multiply by x minus 4 here, and I multiply by x plus 4 here, and I get 4x squared plus x minus 16x minus 4 equals x minus 4x squared plus 4 minus 16x. And now I will organize this term. So those two cancels out, and we get here 8x squared equals 8, divide by 8, take the square root. So those are P and Q. And since P is smaller than Q, then P is minus 1 and Q is 1. This is C1. Now the last part, C2, we have to find the area enclosed by the graph of f and inverse of f. So we want to find this area that is enclosed by two functions, we have to do the integral over the subtraction of the two functions. Now theoretically we need to know which function is on top, and from that to subtract the function that is on bottom. But here it doesn't really matter, because if we're not going to do it the right way, we're going to get a negative answer. But since area cannot be negative, we're simply going to take it as positive. So I just write f minus the inverse of f, but it might be that this is the inverse of f minus f, but as I said, it doesn't really matter. And here we have to take the two intersection points, which will be P and Q. P is the smaller one. So the area is the integral over 4x plus 1 divided by x plus 4 minus 1 minus 4x divided by x minus 4 dx, and the integral is between negative 1 and 1. This integral is calculated using the calculator. I could do a few more steps to show that it comes down to a rational term that have a numerator and denominator, and we cannot integrate it so easily, but we can use the calculator, and we get the final answer here of 0.675. This is the answer for C2.